Okay guys, here we go. Bear with me. This is my first attempt at actually trying to teach you guys new material through this video, so we're going to see how this goes. So what we're doing today is we're going to look at the graph of both sine and cosine. Now the first graph I've given you here, this is the graph of y equals the sine of x. So if you actually graph y equals sine of x, this is what your graph is going to look like. Now the good news for you guys is I am never making you graph these things physically like you did in algebra and trig. You never have to graph these things by hand for me. In fact, I'm really going to keep this pretty basic. So when you guys are asked to do your homework for the graphs of sine and cosine, I'm only going to ask you to find me two things. The first thing I'm going to ask you to find is the amplitude of the graph. Now the amplitude of a sine graph, and really the same thing of a cosine graph, is going to be the distance from here, the x-axis, to a maximum. Or it could be the distance from the x-axis to a minimum. Notice that that distance is the same. So in this case, the distance from pi over 2 from the x-axis here up would be a distance of 1. So this 1 right here is the amplitude. This length of 1 here is the amplitude. So we say that the graph of y equals the sine of x normally has an amplitude of 1. Now, to compare that to something, notice what number's in front of the sine. There's an unwritten 1 right there. That 1 is a multiplier, so that's technically a vertical stretch. I'm running out of room here. By 1. I'll get better at this as the time goes. Whatever your vertical stretch or shrink is going to wind up being the amplitude. So we'll talk more about that on the next example. Now, something else that I want to show you guys is this. The period of a graph, that's the next thing we're going to find, is we're going to find the period of a function. This graph of sine is said to be periodic, meaning that it repeats over a certain length of time. The period is the minimal horizontal distance I can travel before my graph shape starts to repeat itself. So if I start here at 0 and I trace my graph will not start to repeat until right there. After that, it's going to continue to do the same thing. So notice the horizontal distance that I traveled. I traveled a distance of 2 pi away. So we would say that the period of that function, the normal function of sine x, is 2 pi. That's the normal period of the sine graph. Now, what transformation might affect the length? Well, there's only going to be one transformation that affects the length of the period, and that would be if I stretch or shrink my graph horizontally. So that's really where we need to spend our big bulk of our time here, is how do you know when you have a horizontal stretch or shrink? Well, for that, I want you to focus on the number that's in front of the x. This is where I'm looking to find my horizontal stretch or shrink. It's the multiplier in front of x. So my vertical stretch or shrink is out here. My horizontal stretch or shrink is in here. So if I go to a new screen and show you guys now a new slide. Try this. I think this is going to work okay. All right, so if I give you this example next, we're going to look at f of x equals 3 times the sine of x. Now, if I think about transformations here, notice that that 3 is a multiplier outside of my function. So therefore, we can say that that is a vertical stretch by 3. Well, what I'm going to be asking you to find on these problems is I'm going to ask you to find me the amplitude, and I'm going to ask you to find me the period. Remember, my normal amplitude was 1, so amplitude is real easy. If my normal vertical distance from the x-axis to the top or low point is 1, this just stretched me vertically by 3. My amplitude of this function is 3. That's it. So whatever this number is going to be your amplitude. Now, the period of the function is going to be normally 2 pi, but that needs to be multiplied by any horizontal stretch or shrink. Now, the horizontal stretch or shrink is found by looking at the number in front of x, which in this case is just 1. So there has been no horizontal stretch or shrink here. So the normal period was 2 pi over 1. It has a horizontal stretch or shrink by 1, stretch by 1. So I'm going to multiply the normal period by 1, which doesn't change it, so this one has a period of 2 pi as well. So those would be my answers for this question. This function has an amplitude of 3. It has a period of 2 pi. So let's now move on to our next example. So for the next example, we're going to look at this one. If I give you g of x equals negative sine of 3x. Okay, so what's my vertical stretch or shrink factor? Well, there's a 1 here. So this thing has a vertical stretch or shrink by 1. Okay? Does that change my amplitude? My normal amplitude is 1. This didn't change it. So my amplitude of this function is 1. So I am done with amplitude. But when I go to do the period of the function would normally have been 2 pi over 1. But is there a horizontal stretch or shrink? Now, this is the tricky one. So we've got to look at this 3 and say, is that a horizontal stretch or shrink? And this is different from vertical. Find the number in front of x. In this case, the number in front of x is 3. So I've got to flip that number over. The number in front of x is 3. I'm going to write that as 3 over 1. That means there's a horizontal stretch or shrink by 1/3. You always have to flip that number over. So in this case, there is a horizontal shrink by 1/3. So now that I know that I've got a shrink by 1/3, I take 2 pi over 1 times 1/3. That gives me a period of this function of 2 pi over 3. That's my period of that graph. Let's try one more for sine. So for this one, we're going to look at this. If I give you g of x equals negative 3 sine of x over 7, I have a vertical stretch by 3. Don't let that negative fool you. That's just a flip over the x-axis. That doesn't matter. And now, what's my number in front of x? Well, the number in front of x is really a 1/7. So remember, I have to flip that number over. So this one actually has a horizontal stretch by 7. Remember, horizontal stuff is inside, vertical stuff is outside. So when I go to do the amplitude of this, the amplitude is simply whatever my vertical stretch or shrink is. So the amplitude is 3. To find the period, I'm going to take my normal period of 2 pi over 1, but I am going to multiply that by 7 over 1, whatever my horizontal stretch or shrink is, giving me a period of this function of 14 pi.